Chapter 3. Almost all aspects of life are engineered at the molecular level, and without an understanding of molecules, we can only have a very sketchy understanding of life itself. That's a quote from Francis Crick of Watson and Crick, who discovered the double helix structure of DNA. So in this chapter, we're going to talk about molecules and compounds. We've talked about atoms and elements and isotopes. So how many different substances exist? There's not an answer to that. So if we think about it, elements can combine with other elements to form compounds. There's 91 elements, and so even if you just had two elements together, that's an awful lot of different possibilities. But you can have 3 or 4, you can have like 6 compounds between nitrogen and oxygen. So there's just a mind-boggling number of compounds that exist. And so the diversity of substances that we see in nature, the difference between water and gases and rocks and all these different things, is a result of the ability of elements to form different compounds. So when elements combine to form a compound, their properties change in sometimes very dramatic ways. So hydrogen and oxygen are the 2 elements that are present in water. They have boiling points way below 0. These are both gases at room temperature. Hydrogen is explosive, and oxygen is necessary for combustion. So you mix these 2 guys together, and you can make a big kaboom. When these combine to form the compound water, they now are liquid at room temperature with a boiling point of 100 degrees Celsius. And not only are they not flammable, but they can be used to extinguish flames. So when elements combine, we get an entirely new substance, and you can't predict the properties of that substance based on the properties of the elements involved. So a mixture is different than a compound. We talked about this in chapter 1, I think. So in a mixture, you can have different elements mixed together in any proportion. An example would be in a balloon containing hydrogen gas and oxygen gas. And you could put more oxygen gas in, or you could put more hydrogen in. The proportions there are variable. You can change them. In a compound, you have definite proportions. That's what we were talking about in chapter 2. The elements combine in a particular, defined, definite proportion. So for water, that is 2 hydrogen atoms for every 1 oxygen atom. We looked at this in terms of masses in chapter 2. Now we're looking more at the atoms. So it's 2 hydrogen atoms to 1 oxygen atom.